Welcome to this class. In this class, we study about the D flip flop. So, in D flip flop, uh, is similar to your SR flip flop, but the name D suggests that it is a data flip flop. So, it is mainly used for data transfer. The one way to eliminate the intermediate condition of SR flip flop is to ensure R and S never equal to 1 at the same time. This is done by D flip flop. So R and S. So this R and S will never equal to 1 at same time. At same time, this R and S will never be equal to 1. So this is ensured by a flip flop called D flip flop. D flip flop. So in D flip flop, you are going to ensure that R and S will never be equal to 1. So next one, the D type of flip flops are constructed from the gated SR flip flop with an inverted added between S and R. So how we are going to construct this D flip flop? The D flip flop you can easily construct. So we are knowing we are having the S and R flip flop. So these are the two inputs of this flip flop, and we are having the clock signal. See, we can take it as clock here, CLK clock, and this is Q and this is Q complement. So this will be your SR flip flop. So for D flip flop, so we are taking this SR and we are inverting the input and D. So this and the clock signal is also being taken. The clock signal CLK clock is being taken, and this flip flop so this one we call as the D flip flop. So we are going to invert. Say if D is equal to 0, then S equal to 0, but R is equal to 1. When D is equal to 1, the S equal to 1, but R is equal to 0. So only 0, 1 and 1, 0 condition will appear as the input to the D flip flop. So remaining no input will be applying for the D flip flop, and correspondingly you will be getting for S equal to 0 you will be getting Q equal to 1. For R is equal to 1 you will be getting Q equal to 0. So like that we are having two conditions only, and it has two inputs. One is D and other is a clock pulse. It has two inputs, one is D and other is clock pulse. It is modified version of SR flip flop. D flip flop is a modified version of SR flip flop, and D input is directly connected to S input and is complemented is connected to R input, that we have seen here. Now we see this one. See here, see this one, we are having the D input here, and D input, the clock is also there, and R. We are connecting an inverter, and from the inverted value we are connecting it to the R. So this is the truth table. Below which we can see the truth table of the D flip flop. So when clock is equal to 0, when we give clock is equal to 0, the input which we give for X will not be making any changes to this flip flop. So whatever the input which you give, if you give clock as 0, whatever the input which you give, it will be in the previous state. So sorry, it is in the present state. So the present state will be equal to the previous stage. So that is Qn plus 1 is equal to Qn. Qn plus 1 will be equal to Qn when D is not given any input, or D is not given any input, so that you are switching off the D flip flop. So clock is not given. Next, what happens next if you are giving a clock here? Next, if you are giving a clock here, clock 1 is being given, clock 1 is given, and D is given as 0. D is given as 0. Then we can see the output Q will be 0. Output Q will be 0. Output Q will be 0. And next you are giving 1, then the output Q will be 1 here. Output Q will be 1. So first is reset condition, then next comes as set condition. So these two conditions will be there when you are giving the value of D. D is equal to 0 when you are giving D is equal to 1. Correspondingly, Q1 plus 1 is equal to 0 and Q1 plus 1 is equal to 1. So these are all the only two conditions which we are getting when we are giving the input D flip-flop. Next one, we see about the truth table. So truth table will be similar to your this one, clock 0 x q1, and from this truth table we can derive the characteristics table. So for characteristics table, you can see we need this, the q1, qn plus 1 and d. So for q1 we give 0 0 0 1 1 0 1 1. So when q1 is equal to 0, what happens? So when d is equal to 0, what happens to the q1? What happens when d is equal to 0? What happens to the q1 plus 1? So when d is equal to 0, what happens to the q1 plus 1? Q1 plus 1 is 0. When d is equal to 1, q1 plus 1 is 1. When d is equal to 0, it is 0. When d is equal to 1, it is 1. So that is q1 plus 1 is following the d here. You can easily see that when d is equal to x, d is equal to x means when you are not giving any value to the d, then the q1 plus 1 will be equal to q1, and we are not giving any clock here. Clock is not given. The present state is equal to the previous state only when the input is not given to the D flip-flop. That means it is storing the data. അതായത് ഒരു ഫോർ എക്സാമ്പിൾ ഒരു ചിപ്പ് എടുക്കുക, ഒരു ചിപ്പിൽ നിങ്ങൾ പവർ സപ്ലൈ ഒന്നും കൊടുത്തിട്ടില്ലെങ്കിൽ എന്താ സംഭവിക്കുക? നേരത്തെ പ്രോഗ്രാം ചെയ്ത് വെച്ച program. So before that you have programmed some program to this chip. That program will be there inside the chip, and after, if you are giving any clock pulse, if you are giving any supply, then you can make modification. So that thing is being told in this truth table. So now when q1 is equal to 1, so same thing. Then excitation table means we know we need q1 plus 1 and d. So we taken 0 0 0 1 1 0 1 1. So for q1 is equal to 0, q1 plus 1 is equal to 0, what is the d? q1 is equal to 0, q1 plus 1 is equal to 0, d is 0. When q1 is equal to 0, q1 plus 1 is equal to 1, d is equal to 1. So this is same 0 1 we are getting. So we have taken the excitation table. We have from that excitation table, from this characteristics table, we have made this k map. We have plotted the k map. We have taken q1 here and d here, and we need to find q1 plus 1 value. q1 plus 1 the value when d is equal to, when q1 0 1 0 1, when q1 and d is equal to 0, it is 0. When q1 and d is equal to 1, it is 1. It is when q1 is equal to 1 and d is equal to 0, it is equal to 0 and it is equal to 1. So that is q1 plus 1 is equal to d. 1 plus 1 is equal to d. So this is what we got here. q1 plus 1 is equal to d. So this is what about the excitation table of D flip-flop. Next we see about the JK flip-flop. So first we have seen about SR flip-flop, then we have seen D flip-flop. Then now we see about the JK flip-flop. Then afterward we see about the T flip-flop. Okay, fine. Now